Hello everyone. We're going to continue our discussion of linear relationships. Over the last couple of days, we've developed our understanding of linear relationships, and we said in our last video that there are three different ways we can think of a linear relationship. The first way we spoke about was in terms of a rule, an equation that follows the format y equals mx plus c. Okay, so for example, I might have a relationship between two variables y and x such that y equals 2x plus 5. And that follows that format, so that means that our variables x and y are in a linear relationship. The second way that we spoke about it was in terms of a table of values, where for every 1 that my x value increases, my y value increases by a set amount. So if my x value increases by 1, my y value might increase by 2. And if for every 1 that my x increases, my y increases by the same amount every time, then x and y are in a linear relationship. And the third way that we thought about it was in terms of a graph, where if I plot these points from a table of values, and that gives me a straight line graph, then my two variables, x and y, are in a linear relationship. In the last video, we spoke about the gradient, and we said that the gradient can be thought of in three different ways, according to these three different understandings of linear relationships. We said that we can think of the gradient as whatever number fits the m slot of my rule here, y equals mx plus c. So in this example, my gradient would be 2. We said I can also think of it as, in terms of a table of values, for every 1 that my x increases, how much does my y increase? Which would give me the 2 as well. And the third way we thought about it was in terms of the slope of this line, or the steepness of this line. How steep is it? So for every 1 unit that I go across, how many units do I have to go up? And following this example, it would mean that if I went across 1 unit, I would have to go up 2 units to get back to the graph because I have a gradient of 2. I just want to spend 1 minute now talking about an idea that I'm sure you know a bit about already, and that is, if that's what my m represents, then what does my c represent? What does this letter here mean in terms of my linear relationship? So if you'll remember, in the situation we spoke about with the DJ in the last lecture, in the last video, we said that C was like the fixed cost that doesn't change depending on how long the gig is. Let's see if we can apply that same understanding to these three different ways of seeing the linear relationship. So C, which is the fixed cost, the thing that doesn't change depending on how the other variables change, is the thing that's in this C. So here it would be 5. And I'm going to think about it, if I'm thinking about this rule, as the thing that doesn't change. It's not connected to either of the two variables. In terms of a table of values, I can think about it as the value of y when x equals 0. And that's because if x equals 0, then m times x will also equal 0, so I can ignore that, and I just get y equals c. So I can think of c as the value of y when x equals 0. And if I jump down to my graph, I can think of c as being, I'm going to apply this understanding here, when x equals 0, well, this whole line here has the value x equals 0. And this whole line here is the y-intercept. So I can think of my c as being this point here on the graph. the value of y when x equals 0, which I can think of in terms of my graph as the y-intercept. Now that we have a full understanding of linear relationships with the gradient and the y-intercept, let's talk about the next thing that we're going to be doing in this unit, which is finding the rule. So a very common test or exam question is going to give you a graph or a table of values or a situation, and you'll need to find the rule in the format y equals mx plus c that fits that line, that fits that linear relationship. And there's three main different ways that we're going to find the rule, and in this video I'm just going to talk about the first one, and that is finding the rule by first, so this is just the first way that we're going to find the rule, and that is finding the rule by first finding the gradient and y-intercept. So my steps for this are going to be to look at the graph that I'm given, the line on the graph that I'm given. First of all, to find the gradient of that graph by picking 2 points to calculate the gradient. Which we spoke about as being the rise over the run. Then I'm going to find the y-intercept. And finally, I'm going to use those 2 bits of information to write the equation, where the gradient that I calculated here becomes my m and the y-intercept becomes my y. Let's do 2 quick examples of this. So I've got 2 lines here on graphs. Let's look at this first one. So the first thing I'm going to do is pick 2 points to calculate the gradient. So let's say, what should we do? Let's pick this point here, which has an x value of 0 and a y value of 1. Now, if I pick another point, let's say this point here, it has an x value of 2 and a y value of 2. That means that I've had to go across 2 units to go up 1 unit. So my gradient over here, which I'm going to call m, equals the rise, 1, over the run, which was 2. Next I'm going to find my y-intercept, which I've already circled. It's this point over here, and it's got a value of 1. So my y-intercept, which is c, equals 1. Now I can use that to write my rule, which is y equals mx plus c, so therefore y equals a half x plus 1. Let's do one more example. Let's do this one here. I'm going to pick 2 points on this graph. Let's say these 2 points. It's always easy to pick points that fall on the axes because that makes it easy for me to see what their values are. So this point here has an x value of -1 and a y value of 0. And this here has an x value of 0 and a y value of -1. That means I've gone across 1 unit and down 1 unit. I've gone down. That means that my y value has changed, not by 1, but by -1. I've gone down 1. So if my rise over run, my rise, well, it's actually a fall, not a rise. So I've got a rise of -1 and a run of 1, which just equals -1. And my c, my y-intercept, is over here, down at -1. Let's put that into the equation, y equals mx plus c. So I'm going to get y equals -1x plus -1. And I'm going to clean that up a bit. if I have negative 1 times x, that just equals negative x. And if I have plus negative 1, well, that's just the same as minus 1. So my equation here becomes y equals negative x minus 1.